Welcome back, guys. So I have got this nice question from RMO 2001, which is asking us to find all the primes p and q for which this expression will be a square. So when you look at this expression, what's the very first thing that comes to your mind? The very first thing that comes to my mind, and should probably yours, is that this equation is symmetric. And I want you to remember this. Whenever you have the symmetric equation, always test the case p is equal to q. Always test the equal case. So if I test this, let's see what happens. If p is equal to q square, let's see what happens. P square, then it will be 7q square, it will be q square, and sorry, this will be 7p square, okay, and this will be p square as well. This will be q square, which will give me 9p square is equal to k square. This will give me 3p is equal to k. Since 3 is an integer and p is a prime number, this will always be integer, which means for all p and q values where p is equal to q, this will work, which means 2 and 2 will work, 3 and 3, all prime numbers, 5 and 5 will work, and so on, where they are equal. What if they are not equal? What happens if they are not equal? P is not equal to q. So by loss of generality, without loss of generality, we can assume p is greater than q for a second. Let's see what happens. I'll bring it down here. Okay, so I have told you this earlier that whenever you have two equations or a single equation, the very first thing that you should always do in number theory is to make factors, because then we can restrict by bounding. Let's see if we can convert this equation into factors. Okay, p square plus 2pq, the very first thing I see is that a perfect square. Okay, this will be p plus q whole square. Okay, and this will be 5pq. This will be k square. I see the differences of a square, so let's apply that. Bring p minus p plus q whole square on the other side. Okay, so now I get two factors, and this was my main motive, and I completed it. Okay, I'm done here, which means I now have I can let this factor be something. I can make cases where this is 5p, this is q, this is 5pq, this is 1, this is 1, this is 5pq, and this is 5q, this is p, this is 5, this is pq, and much more. And there is even worse thing, which is that I can let this minus p be negative, and I can let this negative, which means I'll have negative cases as well, and it will be so much work. It will be a huge work, wouldn't it? So I can let this be negative as well. And to save ourselves from the negative cases, to reduce the cases, we have to prove that these two factors can never be negative, which will reduce almost half of the cases. So let's try it and try to prove that these factors can never be negative. We know that k square is equal to p plus q whole square plus 5pq, right? We can see that k square will always be greater than 0. Anyways, so k square will be greater than p plus q whole square, right? Okay, from here we can take a square root, and it will give us k is greater than p plus q. From here we can bring it on the other side, p minus q is greater than 0. So the smaller factor k minus p minus q is greater than 0, then definitely the bigger factor will always be greater than 0 as well. And we proved that both factors are greater than 0. So let's name them a and b. 5pq is equal to k minus p minus q, okay, and k plus p plus q. So let this be a and let this be b, okay. So now I can make again those cases, but careful that b will be greater than a. Remember this, that b has to be greater than a. So I can make a lot of cases. Let me show you the cases. I'll only do the one case because almost other cases fails. To keep the video short, I'll only do the one case. Okay, so a is equal to, let's say, pq, and b is equal to 5. Okay, I can say like a is equal to 5p, okay, no, 5q, and b is equal to p. Okay, I can make a is equal to 5p and b is equal to q, but b, I told you b will be greater, therefore we can't let that. Okay, b is equal to pq, or I can do like 1 and b is equal to 5pq, and there can be so many other cases. Yeah, a is equal to 5 and b is equal to pq. So I want you to try out all these 4 cases by yourself. You will see that these cases will fail either because 5 will be p will not be greater than q, which I assumed earlier in our case. Don't forget this, we assumed this. Okay, so it has to be greater than p and q, or it will fail the parity. To keep the video short, I'll not do those cases. I want you to do this by yourself. I'll only do this last case because this works. Okay, so if a is equal to 5, let's say k minus p minus q is equal to 5, and b is what, k plus p plus q is equal to pq. Okay, so let's subtract those. We have to remove this k, and we'll get 2p plus 2q is equal to pq minus 5, right? Okay, and what now we can do is that 2p, we can like bring 5 here. Okay, bring 5 here, and pq minus 2p minus 2q. Okay, now what we can do is that we can factor p from here, but before factoring p, let me show you one thing. If I factor p, I'll get q minus 2, right? And then I'll have minus 2q. From here I can factor out 2, this will give me q, so I have to make it here 2, which means I need 4 here. If there was 4, then if I take 2 common, then it will be q minus 2, right? So I have had to add 4 on both sides before this step. So let's do that. 5 plus 4 will be 9, and pq minus 2p minus 2q plus 4. Now let me show you how we'll factor out. So minus 2q, and then we'll get q minus 2. You see, this is 9, and this is p minus 2, and this is q minus 2. Okay, so now we can make 2 factors and we know that p is greater than q, so this has to be greater than this one. Okay, so if this is 3, okay, this is going to be 9 and 1. This is very first factor that we can do. Another factor that we can do is that 3 into 3, but no, we can't do that, because this would mean that this and this are equal, but we know that these are not equal since p is greater than q, right? So the only thing is that we can make that p minus 2 is equal to 9 and q minus 2 is equal to 1. Okay, this will give me p is equal to 11 and q is equal to 3. Okay, so when p is equal to 11 and q is equal to 3, this expression p square 7 plus pq plus q square will be square of some integer. So we found the values. The only eligible cases, the only eligible solutions are p and q, where p is equal to q, and 11 and 3. These are 2 eligible solutions that works. These are solutions that works. Thank you so much, guys. I hope this explanation helped you. Make sure to like, follow, and subscribe. Thank you so much.